Okay, the next topic we are going to talk about is platelets. Well, it says in here platelets and hemostasis, so might as well talk about these two topics. Hemostasis is the process by which we stop bleeding. Don't confuse hemostasis with homeostasis. Right? Okay, so hemostasis is the process by which we stop bleeding. Platelets is part of hemostasis. Hemostasis have 3 steps, and platelets play a role in hemostasis, but it's only one of the steps in hemostasis. So let's take a look at the platelets. Platelets form and function. The platelets are going to be created, again, like any other foreign element, in the bone marrow. Again, we said that we have in the bone marrow a stem cell. Eventually, through a different set of steps, we are going to get a cell called a megakaryocyte. A megakaryocyte is a big cell, and this cell is going to break into pieces, and the pieces are going to be the platelets. Imagine that the megakaryocyte is a cookie. The platelets will be cookie crumbs. We said the total number of white blood cells is approximately, total number of platelets is approximately 150,000 to 400,000 per microliter, as you guys can see here again. Okay, so let's take a look at the characteristics of a platelet. And as you can see, it's these big cells right here. This is a megakaryocyte, and these ones right here are going to be the platelets. As you can see here, the megakaryocytes have a whole bunch of cell organelles. It has granules. Very important that later on we're going to talk about them. You can see again in here megakaryocyte, and then in here you see the platelets. Again, these are like cookie crumbs. So what's the function of the platelet? It has quite a few functions. The very first one, and the one that it corresponds to hemostasis, is that the platelets are going to form something called the platelet plug formation. Right, that's the first part. It's going to be part of the platelet plug formation. Not only that, the platelets are going to secrete some chemicals that are going to produce vasoconstriction in the blood vessel. If you really think about it, when you cut your skin, the first thing that you, for example, you cut your hand, the first thing that you're going to do is apply pressure with your hand in the area that you get the cut. So you apply pressure in order to stop the blood from coming up. Same thing. When you break your blood vessels in areas, for example, in your body, but they are not coming out, your blood vessels will produce vasoconstriction, which is a similar process that the one that you are doing by putting your hand on top of the other hand in order to avoid the blood from coming out. So vasoconstriction is a very important step in homeostasis. In hemostasis. So hemostasis basically has 3 steps that we're going to see later on. One of these first step is going to be vasoconstriction. The platelets have a small function in that as well, because they're going to produce some chemicals that are going to help us with vasoconstriction. Platelets, we said already, that are going to form the platelet plug. Platelet plug is the second step in hemostasis. Not only they do that, but another very important function is that the platelets also are going to produce clotting factors. As you can see here, clotting factors, which are very important because they are going to produce coagulation. The clotting factors are going to be very important in coagulation. So then, how many steps we have then in hemostasis? We have 3 steps. Step number 1, vasoconstriction. Step number 2, platelet plug formation. Step number 3, coagulation. The coagulation is achieved with the clotting factors. Okay, and platelets have quite a few functions in the sense that they participate in all 3 steps. Okay, not only that, they also are going to have other functions, such as, for example, are going to release some chemicals that are going to help us dissolve the blood clot once the blood vessel that is cut is already healed. Okay, so let's take a look in here again. Platelet production. We said that the platelet production happens at the level of the bone marrow by a process called thrombopoiesis, right? And we said that the cell that is going to do that is going to be a stem cell that eventually will create a megakaryocyte. And we said that the megakaryocyte will produce like cookie crumbs, and the cookie crumbs are going to be the platelets. So let's go to the next step then. And the next step in here, we have hemostasis. We said hemostasis has 3 steps. And as you can see here, vascular spasm is step number 1. Vascular spasm or vasoconstriction is the same thing. Platelet plug formation is number 2. And blood clotting or coagulation is step number 3. As we mentioned before, the platelets play an important role in all 3, even though the main thing that the platelets are going to do is going to be the formation of the platelet plug. Step number 1, we said vascular spasm. Again, that's the first step in which the muscle available in the blood vessels are going to produce vasoconstriction. A lot of times this is just as a consequence, for example, the receptors that we have in there produce pain, and this pain production obviously is going to initiate a response from the nervous system producing the vasoconstriction. Platelet plug formation. The platelet plug formation is initiated by the blood. It's initiated in the blood because the blood vessel is going to get damaged. When the blood vessel gets damaged, areas inside the blood vessel are going to be exposed. When they get exposed, collagen is going to get exposed. And this collagen is the one that is going to trigger the addition, the attachment of the platelets to the walls of the blood vessel. Very important step in the addition of these platelets to the blood vessel is the presence of a substance called von Willebrand factor. Von Willebrand factor is like a glue that will help these platelets attach to the blood vessel to initiate the platelet plug formation. So once you have the platelets and the platelets start attaching to the blood vessel, the platelets are going to start producing and releasing some chemicals by a process called degranulation, as you can see here, degranulation. These chemicals that the platelets are going to release, for example, are going to be serotonin. Serotonin also will produce more vasoconstriction. It also have ADP. ADP will attract more platelets to the area that was damaged. And also thromboxane A2, which will promote the platelet aggregation, which is the attachment of more platelets to the initial set of platelets that were attached to the blood vessel. So let me explain this again. First step number 1, vasoconstriction. Step number 2, you have platelets. And let's say these first platelets that you have right here are the very first one that are going to attach to the blood vessel. These first platelets are going to adhere, are going to attach to the blood vessel in the presence of von Willebrand factor. So the first step in platelet plug formation is addition, because these ones, this right here at the very beginning, they are going to go through a process of addition in the presence of von Willebrand factor. And that's why the first step in platelet plug formation is platelet addition. After that, these platelets are going to release the chemicals by a process called degranulation. These chemicals released by degranulation are going to be serotonin, which is going to stimulate more vasoconstriction, ADP, which is going to make additional platelets attached to the initial set of platelets that we have here. And then we have the next one, which is thromboxane A2, which will help attach all these platelets together. Once you attach all these platelets together, this is called the platelet plug. The platelet plug is not very strong. It's like we have a wall of bricks. If you have a wall of bricks only and you lean against it, the wall of bricks may fall. So then how you avoid this wall of bricks to fall, then you're going to use cement. The cement that you're going to put in between these bricks will make this wall very strong and will not crumble. So if we use the same analogy, this is the wall of bricks, but it's not strong enough. The cement would be the coagulating factors, which eventually are going to produce, obviously, coagulation. So then, again, in this analogy, the platelet plug is just the wall of bricks. It's not very strong. So therefore, the next step is going to be the presence of concrete, cement. So you can make this wall very strong and it will not crumble. So then the first step, again, we say vascular spasm, vasoconstriction. Step number 2, platelet plug formation. Step number 3, coagulation. So let's take a look what happens after you form the platelet plug. In this case, we're going to look at the steps of coagulation. And that's what we have right here, coagulation. Coagulation is achieved because in your blood, you have some chemicals called coagulating factors. These coagulating factors get activated 2 ways. One way is the intrinsic mechanism, and the other one is the extrinsic mechanism. It's called intrinsic mechanism because it uses the clotting factors available in your blood. The other one is called extrinsic because it doesn't use necessarily all the factors that you have in your blood, but rather it initiates, for example, because the blood vessel opens. So factors in your blood vessels, after they get broken, initiate the coagulation. So if you use factors that are not all in your blood, then it's called extrinsic. If you use only the factors that are in your blood, then it's called intrinsic. So that means that there are a lot of times in which your blood vessel is not damaged, but since we have coagulating factors in the blood itself, you can initiate coagulation even though you are not bleeding, or at least you are not seeing the blood coming out of your body. This is a problem because that means that, for example, a lot of people can get clots in their blood without they even knowing, and these clots will produce a lot of problems, not only in the heart, in the lungs, in the eyes, in the brain, because these clots are going to get stuck in the tiny blood vessels that we have in the brain, in the eyes, in the heart, and they may produce multiple different types of conditions that are life-threatening. So let's take a look now at how we are going to use this mechanism. So you have an extrinsic mechanism, extrinsic and intrinsic. It's called intrinsic because it uses the factors that are in the blood. There's nothing external. And in this case, it's called extrinsic because you have factors that were not only in the blood, but also outside, and this triggers the mechanism. Now, there are multiple different factors, and these factors are activated in sequence, as you can see right here. You don't need to know these factors and the sequence or anything like that. You just need to know that they can get activated by the extrinsic or the intrinsic mechanism. One very important thing that you need to know is that the end result of the coagulation is that after you activate all these factors, you will activate thrombin, and thrombin will activate fibrin. The fibrin are going to be the fibers, basically the cement that will make this wall that we were talking about very strong. So you have the platelets, which are going to make the wall, and you have in here the cement that is going to be the fibrin. So the bottom line of all this, once you activate the coagulating factors by the extrinsic or intrinsic mechanism, you don't need to know the sequence, you don't need to know which ones are these factors, but you need to know that the end result of it is that you will activate thrombin, and thrombin will activate or will produce fibrin. The fibrin are going to be fibers that eventually are going to produce this very strong mesh that we have in there that will help us stop bleeding.